Hello friends, welcome back. Once again I came here with a new topic called friction. So maybe some of you know what is meant by friction. So if you define what is meant by friction, friction is the force which acts in between the two surfaces. Whenever a body moves or tends to move over the surface of another body, a force which acts between the two surfaces which oppose the relative motion of the body. This opposing force is called what? Friction. This opposing force will be always act against the applied force. So this is the definition for friction. So now let's discuss about in detail what is meant by friction. Let me tell you a simple example here. I have a wooden board here, okay, a wooden board, and over that another body is placed here. So here you can see here the surface of this body and the surface of this wooden board are now in contact. Now it is at rest. We cannot say there is a friction is there, right? Because we are not applying any external force. Now you just think about, I am going to apply a force in this direction. So if you apply a very small force, you may be felt that whenever you are applying a force on a table, first of all the table won't be moving, right? And again if you are applying more force, then only the table will move. So why the table was not in motion when you apply the force sometimes, right? So this is the case I am explaining here. Let's see this one. I am applying a small force on this small body. If I say that force is not enough to move this body towards the right. So what is the meaning here? This is my direction of applying force. But there is a force which opposes this applied force and that act in between the surface of these two bodies, right? And that opposing force is called what? Frictional force. See here, I am applying a force on this body. The body is not in motion. So frictional force is acting. Even though I am applying a force, the body is not in motion because there is a friction is acting against the applied force. And this friction is called what? Static friction. What is the meaning of static? Rest. Here the body is not in motion, but a force is applying, definitely it will move, but it is not moving because there is a force which is acting against the applied force, and that force is called what? Static friction. Now you just imagine I am going to apply more force than the previous case. When the body will now start sliding, at one particular force, say it as at this force, this body now just started sliding. Then we can say that at that particular moment, the static friction is more. The static friction is maximum when the body just started sliding, when the applied force is acting on the body. So there is a static friction is acting against the applied force, right? And during that time we can say that the static friction is maximum, and that is called what? Limiting friction. So maximum static friction acting between the two surfaces when we are applying a force towards this side, and that maximum static friction is called what? Limiting friction. We can make a conclusion from here. When the force applied is slowly increasing, the static friction between the two surfaces is also increasing. At one particular force you are applying, that time static friction is maximum. That is called what? Limiting friction. So this case we can explain here what? The static friction is a self-adjusting force. What is that? Static friction is a self-adjusting force. That means slowly increases and come to a maximum value. Now you just imagine I am going to apply more force than that previous case, right? What will happen here? Now the body started sliding or the body started moving because I am applying more than that limiting force or limiting friction, right? Now you can see here the body is in motion. Now also there is a friction is acting between these two surfaces, and that is called what? Kinetic friction. When the applied force is more than the limiting friction, body now started sliding, or it is in motion, or it is having a kinetic energy, right? So in this time also there will be friction is acting opposite to the applied force. In motion it is, right? So that friction is called what? Kinetic friction. One more point you have to consider here, that what? The kinetic friction will be always less than the limiting friction. Kinetic friction will be always less than limiting friction. That is the next conclusion you have to make here. Now you just imagine, if I am applying more force than this kinetic friction, what will happen now? The body now started accelerating. So what we have discussed in this case, this is the case we have discussed. It's a surface, right? A body is now placed on the surface. Okay, it is not a smooth surface, so definitely friction will be there. I am applying a force in this direction. This is the applied force. So when the force is applied in this direction, there is a force which is acting in between the two surfaces, right? And that force is called frictional force. I have written here with a small f. So applied force will be always opposite to which one? The frictional force. When the applied force is now slightly increases, the friction will also increases in backward direction in such a way that the body won't move here. Still the body is at rest. And that friction we used to say, that is called what? F subscript S, and that is called static friction. Okay, static friction. Now again you are slowly increasing the applied force, static friction also increases, and at one particular force you are applying, the body now just started sliding. And that moment we can say that the static friction is now maximum, and that is called what? Fs max. Fs max, that means static friction maximum, and that is called what? Limiting friction. What is called? Limiting friction. Now you apply more than this limiting friction, now you can say that body now started moving, and then also there will be a force is acting, opposing force will be acting in between these two surfaces when the body is in now motion, and that friction is called what? Kinetic friction. What is called? Kinetic friction, and we used to represent with the F subscript K, kinetic friction. So the same example if we draw with a graph, you see with the graph here, along the x-axis you say that is the applied force, along the y-axis you take it as the frictional force. Now when the applied force is slowly increases, as we already learned here, what will happen? The static friction also increases. So we can draw here a straight line. We can draw here what? A straight line passing through origin. So here the static friction also increases, and at one particular point the static friction is maximum, and that maximum static friction is called what? Limiting friction, or we can note it down here what? Fs maximum, a maximum limiting friction. After that what will happen? Now the limiting friction is now reduced, and the body will now possess what? The body will now possess what? The kinetic energy. And that time the friction is called what? Kinetic friction. Now you can see here, this is kinetic friction will be always less than the limiting friction. Kinetic friction will be always less than the limiting friction, and it is almost constant. So this is a graph connecting the applied force and the friction. But here friction itself, there are two types is coming here. One is static friction and other one is called what? Kinetic friction. So in this graph, this area, the straight line, almost straight line graph, that represents which friction? That represents what? Static friction. That represents what? Static friction. And at this point, maximum point, that is called what? Fs max, that is called limiting friction. And almost a straight line you can see here, this portion is called what? This is the area of kinetic friction. This is the area of kinetic friction. So we have discussed now here about static friction and kinetic friction. Now let's discuss about the laws of friction. What is that? Laws of friction. In the laws of friction, we'll be discussing about laws of static friction and laws of kinetic friction. Now let's discuss about the laws of static friction. The first one, limiting friction depends upon the nature of the surfaces which are in contact. The next one is that the limiting friction is always acts tangential to the two surfaces and in direction which is opposite to the direction of motion. So this is the next law. Next one is the value of limiting friction. The value of limiting friction is independent of the area of contact. So as long as the normal reaction force is not changing, it is independent of area. The next law is here the limiting friction, that is Fs max is directly proportional to normal reaction force. Is directly proportional to normal reaction force. So as you already know, what is a normal reaction force? This is a body which is on the surface, right? So the force is acting here, it is mg acting vertically downward, right? So according to Newton's third law, there will be an equal and opposite force will be acting upward, right? And that is called what? Normal reaction force. So here what is next law is talking about Fs max is directly proportional to R, or we can write here Fx max or the limiting friction is equal to a constant, and that constant we are writing it as mu s. What is that? Mu s into R. So what is Fs max formula? Mu s into R, where mu s is called what? Coefficient of static friction. So laws of kinetic friction, what is the first law? The kinetic friction which opposes the relative motion, and it is almost constant value, and it depends upon what? The nature of contact, okay, or the nature of the surfaces which are in contact. The second law is talking about kinetic friction is independent of the area of contact. The kinetic friction is independent of the area of contact as long as the normal reaction force is not changing. Next law about the law of kinetic friction is that the kinetic friction is independent of velocity. Even though you are increasing the velocity of the body, the kinetic friction doesn't change. The kinetic friction is what? Independent of the velocity of the body. And the next law is talking about the kinetic friction we used to represent Fk. Kinetic friction also directly proportional to normal reaction force. What is that? Normal reaction force. Therefore, we can write here Fk is equal to, avoiding proportionality sign, multiplying with a constant. Here the constant is mu subscript k, that is mu kr. What is that? Mu kr. Here mu k is called what? Coefficient of kinetic friction. So these are the laws of limiting friction as well as what? Kinetic friction. Now let's discuss about what is meant by angle of friction. What is meant by angle of friction? Consider a body, okay? Consider a body which is now on the surface, okay? A body is now on the surface. Just think about a force is now applying on this body, okay? An external force is applying on the body. So definitely you can say here there will be an opposing force will be there. That is called what? Friction. Which friction? If it is not in motion, static friction. If it is started in motion, it may be what? Kinetic friction. So in this case, you just think about this is the static friction. That means there is an opposing force will be acting, and that is said as Fs max. Fs max. That means limiting friction, or we can say that maximum static friction. Now, which all forces may be acting on the system? We can say here there is a mg which is acting vertically downward. Mg which is acting vertically downward. The next one is that is the, according to Newton's third law, that is normal reaction force is also acting upward. Which force? Normal reaction force. Now the question is here, what is the resultant of normal reaction force and limiting friction? What is the resultant of normal reaction force and the limiting friction? So we can calculate the resultant of normal reaction force and the static friction by using which law? That is the parallelogram law or parallelogram method. If you construct a parallelogram, you can see here the resultant of these two become what? The diagonal. So this is the resultant of which forces? resultant of normal reaction force and the static friction, that is called limiting friction. Now just imagine this is the angle theta, okay? The angle theta. Theta means what? Theta is the angle which making the resultant vector and the normal reaction force. What is this angle theta? We can use it here, what? Tan theta is equal to. So from this triangle, if you take the tan theta, opposite side. Here what is the opposite side? This one same, right? That is Fs max. So we can write here what? Fs max divided by, now what is the opposite side divided by adjacent side? What is the adjacent side here? That is written the normal reaction force R. Fs max is equal to mu s into R. What is Fs max divided by R? That is equal to what? Mu s. So what is the main equation we can write here? Tan theta is equal to mu s. So this is another equation we are discussing about. Tan theta is equal to mu s. Mu s is the coefficient of static friction, and here theta is the angle between normal reaction force and the resultant of normal reaction force and the limiting friction, and this angle is called what? Angle of friction. What is called? Angle of friction. Now let's discuss about the another term called angle of repose. In order to explain that what is angle of repose, let me show you what is angle of repose here. I will draw a line here, right? So that, just imagine that is a surface, okay? On that surface, I have kept one wooden board here, okay? And I kept one body. I got a paint bottle, so I kept here, a body here. Now you can see here which all forces will be acting on this one. As we already know, mg will be acting vertically downward, normal reaction force will be acting upward, right? Because this wooden board is now almost parallel to the surface. Now what I am going to do here, I am going to slightly change its angle. Okay, I am just going to slightly change its angle. You see this one? You can see below, there is a line is shown here, right? Now what I am going to do here, I am going to slightly change the angle between this line and this wooden board. Okay, so line represents what? Surface, okay, earth surface, plane surface. See this one? I have changed the angle, but the body is not in motion. Okay, still which one is now more? Static friction will be more. Okay, so static friction is acting in that direction. Again I am slightly changing the angle. Okay, now I am increasing. You can see the body is not now in motion because the friction is more here. Okay, once again I am changing this angle. See this one? Changing this angle, changing. Now you see it is just going to slide here. See? No. See this one? Again I am changing this angle. Now you can see here at one particular angle it will just start sliding. Okay, you see again I am changing this angle. Okay, I am changing this angle. You can see I am just changing this angle. That means you can see here almost this much angle is now here. So the angle is now I am increasing in such a way that, yeah, see this one, at one particular point, or you can see here at one particular of angle, this body now just started sliding. Okay, just think about it's not in motion, it is just begins to slide, think about that way, because I cannot show you properly here, right? So at one particular angle, that is a minimum angle, the object just started sliding, okay, or just started motion, and this minimum angle is called what? Angle of repose. So once again, what is angle of repose? The minimum angle at which the body just started sliding, and that angle, that minimum angle is called what? The angle of repose. Now let's discuss in detail what is meant by angle of repose. So just imagine this is the surface, okay, horizontal surface. Imagine this is the inclined plane, okay, inclined plane. This is the object which I was placed, okay, the object is placed here. You can see here, if I draw from here, there is a force which is acting vertically downward. If the object is having mass m, okay, the object is having mass m, the one force which acts vertically downward, and that is called what? Mg. Now what is the direction of normal reaction? normal reaction force will be always normal to the surface, right? Here the surface is here inclined here, right? So the normal reaction force will be acting like this, okay? The normal reaction force will be acting normal to the inclined surface. So this is the normal reaction force. So here mg is acting vertically downward, but this mg can resolve into two components. You focus on this diagram, you can see here, this mg can be resolved into two components. One is vertical way and other one is horizontal direction. So one is vertical direction and this is a vertical direction and this is the horizontal direction. So if this is the angle theta, what is angle theta? Theta is the angle between the inclined surface and the horizontal surface, right? If this is the angle theta, if you use the trigonometry method, this angle also become theta. This angle also become theta. So hence we can write here, if this is a mg, we can resolve this mg into vertical direction. That can be written as mg cos theta. What is that? Mg cos theta. Same way the other component we can note it down here what? If this is mg cos theta, this become what? Mg sin theta. Mg sin theta. So what we have done here? We have resolved mg vector into two components. One is mg cos theta, other one is mg sin theta. Now you can see one more force is acting. What is that force? That force is called what? Frictional force. What is called what? Frictional force. Frictional force is acting on the surface here, right? In between surface, but I have shown here as a vector notation, friction is acting in opposite direction. So let me ask you one question here. Which force makes this body comes down? That is mg sin theta. We are not applying any force here. This mg sin theta makes this body comes down. And the friction opposing this direction of motion. And this is a mg vertically acting downward. It is divided into two components, mg cos theta and mg sin theta. So what is the opposite of the mg cos theta? That is the normal reaction force. That is the normal reaction force. So in this example, this theta or we can say it as phi also, okay? Phi also we can use it. This theta or phi, here it is called what? Angle of repose. So as we already know what is in by angle of repose, the minimum angle with which the body just started sliding. The body just started sliding, and this angle, this minimum angle is called what? Angle of repose. Now just imagine the body is now just started sliding. That means it is not begin to slide here, just begins to slide. Okay, so during that time all these forces become equal, right? So in that case we can write here, that is f in this direction, mg sin theta in opposite direction. Both become equal now, just begin to slide, right? Both are equal. In that time the f we can write here what? Fs max, that is a limiting friction, maximum static friction at that moment, just begins to slide here, right? So we can write here Fs max, that is a maximum static friction or limiting friction, is equal to, what is opposite force here? That is mg sin theta, equation number 1. Same way, we can see here the normal reaction force must be equal to which one? That is mg cos theta, mg cos theta, equation number 2. If you divide these two equations, just imagine you are dividing these two equations, what will be the final answer? You will be getting here what? Fs max divided by r, which is equal to, see mg will cancel, sin theta divided by cos theta, that is equal to tan theta. So we got here what? Tan theta. Here tan theta, here theta is represents what? Angle of repose. Okay. So theta we have already used there in the angle of friction. So don't be confused here. If you confuse, use the phi term. So I can write here what? Tan phi is equal to Fs max divided by r. So if you use, instead of theta, if you use the tan phi, okay? Tan phi represents what? Angle of repose. So this theta we can be used what? Phi, because theta we have already used what? Angle of friction. So if you write here tan phi is equal to this value, that is tan phi is equal to Fs max divided by R. We have already written that is equal to mu s, correct? And we have already learned about the angle of friction. Tan theta is also equal to mu s, correct? So what we have made a conclusion here, tan phi is equal to tan theta. Tan phi is equal to tan theta. Tan theta means what? Tan theta means angle of friction. Tan phi means what? That is angle of repose. That means the angle of repose is equal to angle of friction. Angle of repose is equal to angle of friction. So these are the formula you have to learn, and this is the diagram you should learn about the resolution of vector. Which vector we are resolving? Mg vector is resolved into two components. One is mg cos theta, other one is mg sin theta. Clear? This is about the next type of friction, and that is called what? Rolling friction. Let me show you here what is in my rolling friction. You can see here a body which is now rolling. You can see here the body which is now rolling on the surface. Here there is a friction is acting. There is a friction is acting between these two surfaces of contact, and that is called what? Rolling friction. What is called? Rolling friction. So in this case, the rolling friction, you say it as Fr. Okay, rolling friction, say it as Fr. Then rolling friction is directly proportional to, once again, normal reaction force. And also the rolling friction is inversely proportional to the rolling body radius. So we can write here what? 1 by R. So we can write this equation as Fr is directly proportional to R by R. R is equal to mu R into R by R. Here mu R is called what? Coefficient of rolling friction. Coefficient of rolling friction. So this relation is only applicable when the body is now rolling without sliding or without slipping. In that case only we can use this equation. So we were discussing in this lesson, in this session we were discussing about what? The three different types of friction. One is static friction, and other one is kinetic friction, and the third one is what? Rolling friction. I hope you understood this topic. Okay, thank you all of you. See you in the next lesson.